Welcome back to our channel. Today we'll be diving into the fundamentals of SQL database migrations. Whether you are a seasoned developer or just starting your journey in the world of databases, understanding this concept is crucial for building robust and efficient application. So let's get started. The foundation of any database is its data types. Before we start defining our tables and columns, we need to understand the various data types available. Remember, they may vary slightly between different database engines. Here are some common SQL data types. Character, variable character for storing character strings. Binary, variable binary for binary data like images or files. Text, medium text, long text for large text data. Blob, medium blob, long blob for large binary objects like images. Integer, small int, big int for integer values. Decimal, float, double for floating point numbers. Date, datetime, timestamp for handling date and time data. Remember, store dates in UTC for consistency. Bool for Boolean values. Enum for creating a list of possible values for a column. Now that we know how to structure our data, let's talk about ACID properties of transactions. ACID stands for atomicity, consistency, isolation, and durability. These properties ensure that our database operations are reliable and maintain data integrity. Atomicity. Transactions are all or nothing. If any part of a transaction fails, the entire transaction is rolled back, leaving the database in its original state. Consistency. Only valid data is saved. Any transaction that violates the defined constraints will be rolled back, preventing invalid data from being stored. Isolation. Transactions do not affect each other. Each transaction is isolated from others, ensuring that they don't interfere with each other's operations. Durability. Written data will not be lost. Once a transaction is committed, its changes are permanent and survive any subsequent failures. Constraints are essential for maintaining data integrity and consistency within a table. Let's explore some commonly used SQL constraints. Not null ensures that a column cannot have null value, making it mandatory for every row to have a value for that column. Unique ensures that all values in a column are different, preventing duplicate entries. Primary key combines not null and unique constraints to uniquely identify each row in a table, often used with auto-increment for automatic ID generation. Foreign key establishes a link between two tables, ensuring referral integrity. When dealing with foreign key constraints, it's essential to specify the actions that should be taken when the reference record is changed or deleted. Let's explore the most common actions. No action, restrict. The default behavior prevents any action that would destroy links between tables. Cascade deletes or updates the child record when the parent record is deleted or updated. Set null allows the column in the matching child record to be set to null when the parent record is deleted or updated. Set default sets a default value in the column if no value is specified when the parent record is deleted or updated. Indexes play a significant role in optimizing database performance. They act like lookup tables that the database search engine can use to speed up data retrieval. Here's what you need to know about indexes. Simple single-column index, created based on only one table column, used to speed up select queries and where clauses. Composite index, created on two or more columns, providing better performance for specific combinations of columns in where clauses. Unique index, prevents duplicate entries in the indexed columns, enhancing data integrity. As much as indexes can improve query performance, they can also slow down data input operations like update and insert statements. So it's essential to find the right balance. Some key points to remember about indexes. Foreign key indexing. Unlike primary and unique constraints, foreign keys are not indexed by default. However, it's a good practice to index them, especially when dealing with large and diverse data. Use explain In databases like MySQL, you can use the explain statement to see which indexes will be used when a query is executed, helping you optimize query performance. Force index. Use with caution. While you can use force index to enforce index usage, it's generally best to let the database engine handle index selection. If you are using Sequelize, a popular Node.js ORM, migrations help manage your database schema changes over time. Here's how they work. Each migration is a file containing two methods, up and down. The up method applies the migration, while the down method undoes it. The database tracks the names of migration files in a special table, ensuring that each migration is applied only once and can be rolled back if needed. To update a table, create a new migration file and implement the necessary changes using the up and down methods. And that's it for our crash course on SQL basics. Understanding data types, constraints, indexes, and how to manage changes using migrations is essential for building robust and scalable databases. If you found this video helpful, don't forget to like and subscribe for more content like this. As always, happy coding, and I will see you in the next video.